We want to match each function or equation with the correct graph. And the point of the question is not to graph each function with technology to match the graph. The point is to recognize the type of function transformation. Notice all the functions are transformations of the basic square root function graphed above. When we have a transformation of the square root function, we can write the function in the form of f of x equals a times the square root of the product of b and the quantity x minus c plus d, where the values of a, b, c, and d indicate the type of transformation. For a quick review, recall the value of a indicates a vertical stretch or compression, the value of b indicates a horizontal stretch or compression, the value of c indicates a horizontal shift, and the value of d indicates a vertical shift. You may want to pause the video and review these notes in detail. Let's start with the first function, f of x equals negative 1 times the square root of x minus 2. Notice we have a equals negative 1 and d equals negative 2. A equals negative 1 indicates a vertical reflection, and d equals negative 2 indicates a shift down 2 units. So if they can visualize reflecting the basic square root function vertically and then shifting it down 2 units, we should be able to recognize the correct graph. A vertical reflection would look something like this. And if the graph is shifted down 2 units, we should be able to find the correct graph. Looking at the 6 graphs, notice the correct graph is C. This graph is the graph of the basic square root function reflected vertically and then shifted down 2 units. For the second function, we have f of x equals 3 minus the square root of the quantity x plus 2. Because we're subtracting the square root, again, we have a equals negative 1. C is negative 2, because x minus negative 2 simplifies to x plus 2, and the constant 3 is the value of d. The graph of the function is the graph of the basic square root function, reflected vertically because a equals negative 1, and then because c is negative 2, the graph is then shifted left 2 units. And then because d is positive 3, the graph is then shifted up 3 units. Analyzing the remaining graphs, notice the correct graph is A. This graph is the graph of the basic square root function reflected vertically and then shifted left 2 units and up 3 units. Let's go ahead and cross off graph A and graph C. And let's skip the third function for now and jump down to the fourth function. We have f of x equals 2 plus the square root of the quantity x plus 3. The x plus 3 indicates c equals negative 3, and the constant 2 is d. This indicates the graph of the function is the graph of the basic square root function, shifted left 3 units because c is negative 3, and then up 2 units because d is positive 2. Analyzing the remaining graphs, notice the correct graph is B. This is the graph of the basic square root function, shifted left 3 units, and then up 2 units. And then the fifth function is the most basic function. We have f of x equals the square root of the quantity x minus 3. This indicates c equals 3. And therefore the graph is the graph of the basic square root function shifted right 3 units, which now focusing only on the second row would be graph E. This is the graph of the basic square root function shifted right 3 units. The two remaining functions are a little more involved because you do have to change the form of the functions to identify the values of a, b, c, and d. Let's jump back up to the third function. To find the values of b and c, we do need to factor 3 from the quantity 3x minus 1, which gives us the square root of the product of 3 and the quantity x minus 1/3. Notice this indicates that b equals 3 and c equals 1/3. Knowing c equals 1/3 makes it easy to find the correct graph. Recall c equals 1/3 indicates is shift right 1/3 of a unit, which is going to be graph F. But let's also talk about the value of B. Because B equals 3, we have a horizontal compression by a factor of 1 divided by B, or 1/3. This would affect the x values, and therefore we'd multiply the x values of the points on the graph of the basic square root function by 1/3, which again compresses it horizontally or to the left, again by a factor of 1/3, and then the graph is shifted right 1/3 of a unit, which does give us graph F. Finally, for the last function, which we know must match graph D, the radicand of 1 minus x is equivalent to negative x plus 1, which if we factor out negative 1, we would have negative 1 times the quantity x minus 1. The given function is equivalent to 2 times the square root of the product of negative 1 and the quantity x minus 1. If we distribute negative 1, we still have negative x plus 1, which is equivalent to 1 minus x. In this form, a equals 2, b equals negative 1, and c equals 1. We could perform the transformations in any order, but because b equals negative 1, we have a horizontal reflection. If we reflect f of x equals the square root of x horizontally, it would open to the left. And then because c is positive 1, the graph is then shifted right 1 unit. And then because a equals positive 2, we have a vertical stretch by a factor of 2, and the graph is stretched vertically, again by a factor of 2. And notice the graph would be graph D, where again this is the graph of the basic square root function, reflected horizontally, shifted right 1 unit, then vertically stretched by a factor of 2. D is the correct graph for the last function. I hope you found this helpful.